Hello, this is Mr. Steenerson, and I'm going to take you through an elevator ride to help us explain balanced and unbalanced forces. So we'll be using a simulation, and I'll pause at different points to explain kind of what's happening with the forces in each of those spots. Okay, one key to understanding a lot of these is the understanding the difference between balanced and unbalanced forces. So we're going to take a look at balanced forces first. That case always means that acceleration is zero. The object is either stopped or moving at a constant velocity. If it's stopped, the velocity is zero and the object's at rest. If it's at a constant velocity, it maintains that motion. They're in motion and they stay in motion for the duration. The next thing we're going to focus on is unbalanced forces. And when there's an unbalanced force, the acceleration is uniform and is not equal to zero. So there are a couple things that we'll be taking a look at when we have an unbalanced force, or in other words, there is a net force. The acceleration of that object experiencing a net force depends directly on the net force. So the greater the force, the greater the acceleration. Less the net force, the less the acceleration. Acceleration also depends, or inversely, on the mass. So if there is a greater mass, the acceleration will be less for the same amount of force. In this simulation, we're going to use an elevator ride to simulate what happens with balanced and unbalanced forces. Note in the start, the forces are balanced, therefore the net force is 0, 784 up and 784 down, and this motion is at rest. We're going to next explore what happens when we have an acceleration. Notice when the elevator is at rest, the forces are balanced. However, when the elevator starts to go upwards, we have an unbalanced force. Now you can see that there's an acceleration upwards, the net force is directed up, and the motion is accelerating upwards. The guy says he feels heavier. That's because the normal force has increased, and so there's more pressure against him from the floor of the elevator. That's due to the acceleration. Mass times acceleration, in this case 4 meters per second, will cause the normal force to increase. Therefore, there's an unbalanced force in this situation. Notice what happens in the next part of the path. Take a quick look at his net force and predict the motion in this next part. The normal force and the gravitational force are again balanced. Therefore, there is no net force, and therefore there is no acceleration. However, his motion is moving at a constant speed. The elevator is still going upwards. In the next part of the path, he's actually going to be slowing down. So the elevator is starting to come to a stop. Therefore, the acceleration is directed downwards. The normal force has decreased in this case. The weight, or his gravitational force, is the same. However, he feels lighter because there's less force pushing upwards on him. So that normal force is less. Therefore, there's an unbalanced acceleration, or an unbalanced force that causes the acceleration downwards at 4 meters per second squared. Lastly, when he comes to rest on the top at the 20th floor, his forces are again balanced.